In this video, we're going to cover 6.2, which is multiplying monomials. So let's go ahead and get to it. We take a look at this top part. There's a lot of vocab in it, which you should know already. The big number is the base, big letter here. Small number in the sky here, the exponent. So when we're multiplying these two monomials, because that's what they are, what we have to do is, what we can do is we can expand these two things. A squared will become a times a. That's what's in parentheses. And then we have multiplication, so we have here. And then we have a cubed, which is just a times a times a. Right? It's a multiplied together by itself 3 times, which is what the second one is. But now, take a look at what we have. We have now not 2 or 3 a's multiplied together. We have 5 a's multiplied together, right? Because we had 2 in the first one, and then we have multiply by 3 on the next. So that's basically just showing you that whenever you multiply two numbers that are the same base with different exponents, or with any exponent, you can just add the exponents. So I'll show you some examples. If you want to fill this out, you can here too. This is just saying that the exponent of a monomial says how many times to use that variable for that base. So probably better in multiplication. Also, something else here, anything to the 0 power, the 0 power is 1. And notice how these two things are actually different, because in the first one, the x is only raised to the 0 power, not the 3. So this would actually be 3 times 1, which is 3. But this over here, it's 3x raised to the 0 power. So this whole thing is just 1. You could even distribute this, be 3 to the 0 times x to the 0, but I don't know if you've seen that. So this would be 1 times 1. Okay, let's do some examples that are a bit more relevant. So for this first one, the key thing to learn from this first one is that you're not going to be combining things that have different bases. So for example, you won't be combining x's with y's or y's with z's, but you can combine two things that are both x's. So we have x to the third here, and then times x to the 7th. So we'll actually have, what you can do is you can add these two exponents together. So you'll have x to the third times x to the 7th. That's going to be x to the 10th. X to the 10th. And then y to the 4th and z, they stay the same because they haven't combined. Okay, so number 2, this is where we're going to introduce some coefficients. As you can see, we have big numbers here too, and not just the exponents. What you're going to do is you're going to multiply these two big numbers together. So we have 2 times negative 10, that's negative 20. Then now we have to combine the x's. We have x squared here, and we have just x, actually x to the first power, kind of invisible, kind of implied. So we have 2 plus 1, and that's going to get x to the third. Okay, so example number 3 and 4. I want you to try those first, and remember, you're going to be combining the a's with the a's, or the x's with the x's, and then you're going to be combining the b's with. Okay, so go ahead and try 3 and 4 first, then come back to the video. Okay, so hopefully you're done with that, and now you're going to see if we get the same thing. So first thing I'm going to do is I'm going to multiply the big numbers, the coefficients. 3 and 7 make 21. And then I'm going to combine the a's, so I have a squared, and then this is actually a to the first power. So we're going to have a squared times a to the first, that's going to be a to the third. And then b, I have 1b here, and then I have b squared here, so that's going to be b to the third also. 1 plus 2, that's equal. Okay, and then for number 4, we have 2 times 8, which is 16. And x squared, x cubed, that makes x to the 5th, right? You add 2 plus 3, and that makes 5. Y to the 3rd and y to the 4th, that makes y to the 7th. Okay, so when you just have simple multiplication like this, a way that I've I've kind of remembered how to do this, or I've told students to remember how to do it, is you're just going to be multiplying the coefficients and then you're going to be adding the exponents. Okay, of course, you're going to be only adding the exponents if they have the same base. Remember, you can't add a's and b's together. You can't combine those two together. They're going to stay separate. So again, you're going to only be adding the exponents if they have the same. Okay, let's move on. So here are 4 more examples that you should have on your habit. I don't know. But again, this is a bit different here. Because if you take a look, we have a number raised to an exponent, and in parentheses raised to another exponent. All of these examples have that. And if you have this situation, what you're going to do is you're going to multiply the exponents together. Why does this work? Well, let's take a look. 2 to the third, that squared, is just going to be 2 to the third times 2 to the third. Right? That's what it means to have something squared, is you multiply it by itself. But now look what we can do. We can say that this is 2 to the 3 plus 3, which is 2 to the 6. Okay? Which is 3 times 2. 2 to the 6. 6 is 2 times 3 or 3 times 2. So again, whenever you have this situation where you have a number raised to an exponent or something raised to an exponent, and in parentheses raised to another exponent, you're going to be multiplying. Misspelled exponent. You're going to be multiplying the exponent. Okay, so for number 6, again, you're going to just be multiplying the exponents here. So we'll have n to the 10th. And lastly, what you're going to do here is for number 7 and number 8 also, since we have kind of more than one thing going on inside the parentheses, we're going to actually have to basically distribute the square that's on the outside to all 3 of these things. So we're actually going to have like 6 squared x to the 6, 3 times 2 is 6, and y squared. So 6 squared, that's actually going to be 6. So whenever your thing on the inside has more than one thing going on inside, you're going to have to distribute the exponent on the outside. Okay, so go ahead and try number 8 on your own. Remember to distribute the exponent on the outside, and then you're going to have to combine the x's at the end. Go ahead and try that. Okay, so hopefully you're here now having finished it. So let's go ahead and distribute this 2. We'll have 2 squared, which is that, x 6, right? 3 times 2 is 6. And then we have an x to the 4th on the outside. So what we can do is we can say 2 squared, that's going to be 4. And then now we can combine the x to the 6 and the x to the 4th. We're going to be adding the exponents if you're multiplying. Have x to the 10th. Okay, so we kind of have, this is what you're going to have on your star chart, basically. You're going to have these rules whenever you take the star, and it's kind of maybe slightly confusing as to what they mean, just because it's like a whole bunch of letters and stuff. But basically, this first one is saying if they have the same base, you can add the exponents. So for example, if I have x to the 5th times x to the 7th to the 12th. If you have a power and then you raise it to another power, you're going to be multiplying the exponents. That's kind of what we just covered. So for example, if I have x to the 5th, this time I have it raised to the 7th power, it's going to be x to the 7 times 5, which is x to the 5. And lastly, if you have something a lot going on inside, if it's just like xy or 6xy or something like that, you're going to have to basically distribute the power on the outside to each term on the inside. Had 2x squared d I'm going to raise this to the third power. We're just going to basically distribute this 3 to all. So we'll have 2 to the third, which is 8. X, the 2 times 3, which is 6. And z. Okay, and these last two I think are kind of silly, so we're not going to do them. But basically, that's going to be it for this lesson. And you can close out of this if you want, but I do have something in store for you because one of my students has been asking me to do this for them. And I decided, you know, since I'm at home recording these videos, why not? So you'll see what it is in just a second. I want to pull it up. All right, if you don't know what game this is a game called Osu. One of my students, and you know who you are, has been asking me to show me play this game for like forever. And I guess if they don't watch this video, then they're not going to be able to see it ever. But I thought I would just play a map. Why not? Just appease the masses. If you don't know how this game works, basically I just control my cursor using this tablet. This is what I was using to make those videos too. And basically you just have to click the circles. And how you click them is I use my left hand, and I'm going to be pressing just 2 keys, which is for me A and S, and you just have to click them to like the rhythm of the song. So that's kind of why I have like a hand cam instead of face, just so I don't know. Oh well, you'll see anyways. I'm gonna play this map, and that's gonna be it for this video. So yeah. Alright, let's do it. Alright, well anyways, yeah, that's gonna be it for this video. Hopefully you enjoyed it, and yeah, hopefully you learned something today, whether it be about math or OC. I'll see y'all next week. Bye.